6434. What is the correct departure procedure at a non-towered airport? A. The FAA-approved departure procedure for that airport. B. Make all left turns, except a 45-degree right turn on the first crosswind leg. C. Departure in any direction consistent with safety after crossing the airport boundary. The correct answer is A. At a non-towered airport, where there is no control tower or air traffic control services available, pilots are responsible for following the appropriate departure procedures to ensure safe and orderly operations. The specific departure procedure to be followed at a non-towered airport is typically outlined in the FAA-approved documentation for that particular airport. The FAA, Federal Aviation Administration, provides guidance and establishes standard procedures for non-towered airports to promote safety and efficient traffic flow. These procedures take into account factors such as airport layout, runway configurations, nearby airspace, and local traffic patterns. The FAA-approved departure procedure for a non-towered airport may include specific instructions regarding the direction of turns, altitude restrictions, radio communication procedures, and any other relevant considerations to ensure safe departures and minimize conflicts with other aircraft. It is important for pilots to familiarize themselves with the specific departure procedures outlined in the FAA publications, such as the Airport/Facility Directory, A/FD, or chart supplements, formerly known as Airport/Facility Directory, A/FD, for the airport they are operating from. These publications provide valuable information regarding airport operations, including any unique departure procedures or considerations. By following the FAA-approved departure procedure for the non-towered airport, pilots can maintain orderly and safe operations, avoid conflicts with other aircraft in the vicinity, and ensure compliance with applicable regulations and best practices. Therefore, at a non-towered airport, the correct departure procedure is to follow the FAA-approved departure procedure specific to that airport, as outlined in the relevant FAA publications. 6460. When operating under VFR at more than 3,000 feet AGL, cruising altitudes to be maintained are based upon the A. True course being flown. B. Magnetic being flown. C. Magnetic heading being flown. The correct answer is B. 5,500 feet, etc., and at even 1,000 feet plus 500 feet when heading west, e.g., for 1,500 feet, 6,500 feet, etc. This rule helps to ensure vertical separation between aircraft flying in opposite directions. For example, if a pilot is flying a magnetic heading of 090 degrees eastbound, they would choose a cruising altitude of 3,500 feet, 5,500 feet, or any other odd 1,000 feet plus 500 feet. On the other hand, if the pilot is flying a magnetic heading of 270 degrees westbound, they would select a cruising altitude of 4,500 feet, 6,500 feet, or any other even 1,000 feet plus 500 feet. By selecting cruising altitudes based on the magnetic heading being flown, pilots maintain consistent separation and enhance overall flight safety. It helps to ensure that aircraft traveling in the same direction are flying at different altitudes, reducing the risk of mid-air collisions. It's important to note that these altitude rules may vary in specific airspace, such as within controlled airspace or under instrument flight rules, IFR. Pilots should consult the appropriate regulations, such as the Aeronautical Information Manual, AIM, or local airspace restrictions, to determine the exact cruising altitude requirements for their specific flight. Therefore, when operating under VFR at altitudes above 3,000 feet AGL, the cruising altitudes to be maintained are based upon the magnetic heading being flown, considering the magnetic variation in the area. 6461. Which courses and altitudes are appropriate for VFR aircraft operating more than 3,000 feet AGL, but below 18,000 feet MSL? A. True 0 degree to 179 degree inclusive, odd thousands plus 500 feet. B. Magnetic course 0 degree to 179 degree inclusive, even thousands plus 500 feet. C. Magnetic course 180 degree to 359 degree inclusive, even thousands plus 500 feet. The correct answer is C. When operating visual flight rules, VFR, in controlled airspace at altitudes above 3,000 feet above ground level, AGL, but below 18,000 feet mean sea level, MCL, pilots must adhere to specific course and altitude rules to ensure safe separation between aircraft. The appropriate courses for VFR aircraft in this altitude range are magnetic courses ranging from 180 degrees to 359 degrees inclusive. This means that the aircraft's magnetic heading should fall within this range when flying in the specified airspace. In terms of altitude, VFR aircraft in this altitude range are required to fly at even thousands plus 500 feet. This means selecting an altitude that is an even 1,000 feet, e.g., for 1,000 feet, 6,000 feet, etc., and then adding 500 feet to that altitude, e.g., for 1,500 feet, 6,500 feet, etc. For example, if a pilot is flying a magnetic course of 220 degrees and operating at an altitude between 3,000 feet AGL and 18,000 feet MSL, they would need to follow the appropriate altitude rule and select an altitude of 6,500 feet. This ensures vertical separation between aircraft and helps to maintain a consistent altitude profile within the specified airspace. It's important to note that these course and altitude rules are specific to VFR operations in controlled airspace and are designed to ensure safe and efficient traffic flow. Pilots should be familiar with the relevant regulations and consult aeronautical charts, such as sectional charts or en route charts, to determine any additional restrictions or requirements specific to the airspace they are operating in. Therefore, for VFR aircraft operating more than 3,000 feet AGL, but below 18,000 feet MSL, the appropriate courses to follow are magnetic courses ranging from 180 degrees to 359 degrees inclusive, and the altitudes to maintain are even thousands plus 500 feet. These rules help to ensure proper separation and enhance overall flight safety in the specified airspace. 6486. Completion of an annual and the return of an aircraft to service should always be indicated by A. Conduct of a test flight and the appropriate logbook entry. B. The appropriate entries in the aircraft maintenance records. C. The relicensing date on the registration certificate. The correct answer is B. After completing an annual inspection and ensuring that all necessary maintenance and inspections have been performed, it is crucial to properly document these actions to indicate that the aircraft is ready to return to service. The appropriate way to do this is by making the necessary entries in the aircraft maintenance records. Aircraft maintenance records serve as a comprehensive historical record of the maintenance, inspections, repairs, and alterations performed on an aircraft. These records are crucial for maintaining compliance with regulatory requirements, ensuring airworthiness, and providing a traceable history of the aircraft's maintenance. When an annual inspection or any other significant maintenance action is completed, it is necessary to record relevant details in the aircraft maintenance records. This includes documenting the date of the inspection or maintenance action, the scope of work performed, the components or systems inspected, any repairs or replacements made, and the signatures of the individuals involved in the maintenance process. By making the appropriate entries in the aircraft maintenance records, it provides a clear indication that the annual inspection or maintenance action has been completed and the aircraft is deemed airworthy. These records also serve as a valuable resource for future maintenance and for demonstrating compliance during regulatory audits or aircraft transfers. It is important for pilots, aircraft owners, and maintenance personnel to understand the significance of accurate and up-to-date aircraft maintenance records. Compliance with record-keeping requirements is not only a regulatory obligation, but also a best practice for safety and proper aircraft management. Therefore, completion of an annual inspection and the return of an aircraft to service should always be indicated by making the appropriate entries in the aircraft maintenance records. This documentation ensures compliance, facilitates airworthiness, and provides a comprehensive maintenance history for the aircraft. 6488. An aircraft's last annual inspection was performed on July 12th this year. The next annual inspection will be due no later than A. July 13th next year. B. July 31st next year. C. 12 calendar months after the date shown on the airworthiness certificate. The correct answer is B. The next annual inspection for an aircraft is typically determined based on a 12-month interval from the date of the previous annual inspection. In this case, the last annual inspection was performed on July 12th of the current year. To calculate the due date for the next annual inspection, you would add 12 months to the date of the previous inspection. Since July has 31 days, the next annual inspection will be due no later than July 31st of the following year. It's important to note that the specific due date for the annual inspection may vary depending on the regulations and maintenance practices of the particular jurisdiction or aircraft type. However, the general principle is to perform the annual inspection within a 12-month period to ensure the continued airworthiness of the aircraft. Therefore, based on a 12-month interval, the next annual inspection for the aircraft will be due no later than July 31st of the following year after the last annual inspection was performed on July 12th.